Yeah, it was cosecant 2x.
Oh,
And it was an integral.
was that one?
Yeah.
Well, you got two choices. You know you've got the little formulas that you memorized for cosecant, right? Do you remember that you have those? So you can use those if you remember that you have them. So I will pause while you find them. And then the 2x part is just chain rule. Backwards chain rule, so you'll divide your answer by 2, the derivative of the inside. I'll show you that part in a minute. Just going to try and remember where our, there we are, page 371. No, it isn't page 371, I lied. It's page 378. We can do it using right triangles as well. Let's do that. Does that sound like fun?
Oh no.
Sounds like fun. Come on.
Shut up.
So you said it was an identity one. Which identity did you use for it?
I did 1 over sine 2x.
I think Christiana was. Show me.
You used 1 over sine 2x, and then what did you do with it?
I used the identity sine 2x plus cosine.
Mm-hmm.
But I got this from
The
somebody
identity
else.
is 2 times sine of a single x and cosine of a single x, all times dx. You see how she did it?
Yeah, it's
So just recognize that cosecant's 1 over sine. Recognize the sine of a double angle can be separated. And then just use substitution. Let u equal either sine or cosine. It's really your choice. I don't care which one.
But it's in the denominator.
Huh?
U prime is in the denominator.
That's true, it is.
Is that legal?
Wait, how
No.
do you know that 1 over sine 2x is the same as 1 over 2 sine of x?
Okay, so let's start there. You're right. I never thought of that. It's in the denominator. U sub's not going to work. But I know this because I teach trig all day long every day, and I have it memorized. It's just one of your IDs that you learned in trig last year.
Okay.
But it's not going to work. The U sub isn't going to work for this.
Okay, so I got this from someone else, but it was 1/2, and then the integral of sine squared x plus cosine squared x over sine x over cosine x.
Hold on. What did you just say? Let's see if that person knew what they were talking about. Does that person know what they're talking about?
It was, I didn't want to write them out.
All right, let's find
So I
out.
just-
Tell me the integral of what? Tell me what it said. What you said. You may.
It's fine. So basically, I just changed that 1 for sine squared x plus cosine squared x, the one on the numerator.
The 1.
Yeah.
This number 1. Okay.
Set that equal to.
Yep, I like
squared
it.
x plus cosine.
I like it. So far, I'm just going to keep writing it down here. So he said, well, I know that 1 is equal to sine squared x plus cosine squared x.
Oh, okay.
This is a good method. I like this method. This is a good approach to the problem. What did you do next?
Then I split it up.
I love it. So he split it into 2 pieces. Okay, do you all understand where the sine squared x plus cosine squared x came from? Yes or no?
Yes.
Nod yes
Yeah.
and shake your head no, so I can see some visual. Come on, show me. That corner, tell me yes or no. Okay. Do you all understand how sine 2x became 2 sine x cosine x? Nod or shake your heads, one or the other. Thank you. Do you understand that I'm now going to split this into 2 fractions? And then use u substitution on both fractions. Okay, I'm done then. You do it from there. All right, so Morgan, the real question is, would I recognize to do that on my own? And the answer is maybe.
Yeah.
With experience, maybe.
Wait, so I still don't know, like after that,
I did.
we got tangent x plus cosine x.
Well,
How
no.
do we split it
Oh, to work probably. Sine squared x over 2
I just factored that 1/2 out.
sine x, yeah, I would too, but I'm keeping it together so everyone can see. I'm actually gonna split it into 2 completely separate integrals so people could really see it well, hopefully. I would factor the 1/2 out as well. Okay. Then what?
Factor a sine out of the left one and a cosine out of the right
You
one.
could factor a sine out of the left and a cosine. In other words, you could
Or just
cancel
it.
out one of the sines in here and one of the cosines in here if you wanted to. Do you want to? Is that going to be useful?
Can we do use of now?
Could you do a u sub now?
Actually, yeah, factoring those out.
No.
Mm-mm.
There's a denominator.
It's
So we got a 1/2 sine x over, so I'm going to cancel one of these sine x's out. Did you see how I just canceled one of the sine x's out of that?
So that's integral tangent.
There's a denominator.
Yeah, Michaela?
Instead of memorizing like all these identities, which I know we have to,
You don't
But-
have to.
to go around this problem, it would just be easier to know the integral of cosecant, because then you could just set u equal to 2x. So it's negative 1/2 on the outside.
Yeah.
ln of cosecant.
Yep,
plus
that's
cosecant.
just fine. Right up until the A part of getting an A on the test. This is it. This is the A part.
Okay.
That equals stupid.
Yep, that's where I fail.
So, yes, memorize it. Yes, memorize it for ease of use. There are many, many times when you're going to need these, and so you want it. The other one, integral of tangent, get it in your head because it just comes up so much in our next work coming up. So just get them memorized, but in the process, you do need to know how to do them. So on these two, on this one, I would let u equal cosine of x because it's the thing in the bottom. And on this one, I'd let u equal sine x because it's the thing in the bottom, and then they'll unfold nice and pretty. Yes?
I was just wondering whether I could have, because I did it a different way.
Oh, I'm excited to hear.
I used the, what is it called? It's like the derivation of the secant formula.
Okay, so hold on. Set it up for me. I start out with cosecant of 2x dx, then what did you do next?
I took the u substitution of 2x, and I kind of just got that to turn into u.
All right, so that you didn't have to mess with it. I accept.
Then-
And I assume that means I've got a 1/2 du here.
Yeah,
Okay.
and does it make sense that I did the whole cosecant u plus cotangent u multiplied top and bottom?
Oh, nice. I like it. So you took cosecant u and you multiplied it by cosecant u.
Plus cotangent u.
So, and you said top,
Top and
and
bottom.
top and bottom. Cosecant u plus cotangent u over, like this?
Yeah.
Okay, good. Okay, again, how would you know how to do that without CalChat's help or some internet? I'm not sure. It depends on your experience with trig functions, if you can play this game. Well, with the in and out game. All right, Kevin, then what'd you do?
Then take the, well, I don't know if I can do this, but I substituted the bottom.
You did what? You
substituted again,
All right, so
making the
let
bottom V.
W
or
equal,
W, whatever.
oh, you let it be V? I accept. We'll stick with what you have so I don't confuse you. Fine.
And then dv
dV.
became, the negative cosecant, squared u.
Cosecant u, cotangent u,
Cosecant
plus cosecant squared u, du.
And then I
so hold on a second. Let me catch them up to why this is really cool and important. I need color. Yes, by the way, this is a great method too. Both these methods work really nicely.
I found it on page 332 as well. Example 9 has.
Oh, really?
cosecant
Page
version.
332, example 9. No kidding.
Yeah.
Weird. You mean those examples helped you out?
Yeah.
What a strange idea. And this is a pretty common way to do these problems. If you start to recognize, anytime you got a natural log with some addition inside, that's probably what you're gonna multiply top and bottom by. All right, so then I put a 1 under this cosecant u and I distribute it. When I distribute cosecant u, I'm stopping while you look at it. Alger's already checked out. What does this equal? Cosecant squared, do you see that? Check. Cosecant cotangent? Check. So if I let u equal the bottom, the top unfolds. So basically what we did is we multiplied top and bottom by whatever we wanted du to equal. Times our stuff. Yeah, you're lost, I can see. Nice work. And if you sub everything, it will unfold nicely and come out to simple too. How many of you think you'd recognize the simple identity here? Kinda. The trickiest part, I think, will be recognizing that this 1 ends up, we need it. Because as Andrew pointed out right away, if we do u substitution right here, we're not gonna work because everything's in the bottom. So we needed something to sub that was a u sub part in the top. How many of you like this, if you memorize the process? Because you get it, you work through it and you get it. So Kevin, you're a star. Nice work. You're a star because you found the example.
With the rule up there, like, because I know when you're doing stuff with the e's and stuff, like the derivative of speed of something, it's like that same thing. Like, how do you know? And then,
How do you know when you're dealing with the trig?
well, how do I know, like, if I use that thing for the derivative, or if the derivative's like the same thing as what it is before? Does that make sense?
No. Somebody help me?
No, because, well, even like 43, for the t squared, or no, for the 2t, when we took the derivative of 2 to the t, that's when we had to use the rule. Or am I thinking of it? Like,
Or was it derivative?
yeah, we're finding the derivative.
Okay.
So for the, wait, is it, I think it's the other way around. I'm not looking at them.
I have no idea.
T squared to 2 to the t. Well, you just have flipped around.
I just
For
flipped
the
it.
2 to the t, that's where you have to use the rule to find the derivative, right?
Yes, because the variable's in the power. That's
So that's why.
That's
if the
why.
variable's in the power, then you have to use that.
if
but
the
if it's-
variable's in the power, you have to use either this one or the integral form of it.
That's what, okay. So if a number is in the power, then the derivative's that same thing. So
Yeah, if the number's in the power, then it's just power rule. Easy. The easiest thing we learned.
got it. Okay.
Good job, guys. Just out of curiosity, Nick, how did you figure that one out?
Oh, the internet.